When you need to create a rule dealing with multiple entity instances or associated entities, you will work with collections. Collection operators let you evaluate the set of elements in entities and associations so that requests sent to a rule can transfer elements between collections or return a result. To illustrate the use of collection operators, we'll use the cargo samples vocabulary, which includes entities describing flight plans, cargo, and aircraft. We want to make sure that cargo manifests match flight plans, and that an aircraft's cargo is appropriate. A plane should not be overloaded, nor should it carry empty lots. And special requirements for cargo, such as refrigeration, should only be assigned to appropriate containers. We'll use collection operators to do these tasks. First, we have to add attributes to the vocabulary to store the calculated values. Because aggregation results are always numeric, we set the attributes as integer or decimal values. We also set some of these attributes as extended transients in the flight plan: maximum weight, minimum weight, and average weight, because their values are of interest to us, yet are not values that we want to add to the record if we store them in a database. Collection operators are defined against aliases that they use in context for their evaluation. So, in the rule sheet's scope, we set the flight plan alias as plan and set the cargo alias as load. It is important to remember to set aliases for the entities you want to use in collections. On the rule sheet, the action section shows non-conditional aggregation operations that use the defined rule operators for collections, as listed under Entity Association Operators. The first one is size, which counts the elements in the collection, rather than any specific attribute. The next four act on the weight attribute. The iterate line in the actions section adds text to each cargo element, a technique that we might use to track processing stages. In the conditions section, we see 3 conditions I created that we will examine. The first ones use the universal quantifier, for all, to check attributes in every instance of the collection. In this case, we want to determine whether the flight number and manifest number agree. As this condition is an equality test, we set true and false columns and messages. The next condition uses the existential qualifier exists to determine whether any of the elements in the collection have the specified attribute value. Here too we set true and false columns and messages on each case. The third condition uses the isEmpty operator to check the whole collection to determine if there are any elements associated with the flight plan. For this condition, we want a message only when it is true. I previously prepared a rule test with 3 requests to see that our collection operators work as expected. Let's run the tests. In the first test, we see messages confirming that the manifest identifiers are correct and alerting us to the fact that there is a refrigeration requirement. The aggregations are all computed. Our aggregation rules performed correctly, and the status tag worked as we intended. It used the iterate operation to set the value reviewed on every cargo item that was processed. In our second test, we see that there is no cargo. The size operator counted 0, and none of the other aggregation operations computed anything. In our third test, we see that neither of its containers requires refrigeration. But one item does have a mismatch on its manifest flight plan identity. All the tests and aggregations on collections functioned as we expected. This completes our overview of Corticon collection operators.